Hello everybody, I'm Arda, and today I'm going to be talking about the paper titled Separable Gain Control of Ongoing and Evoked Activity in the Visual Cortex by Serotonergic Input by Azimi and colleagues from 2020. So this is pretty much a new paper. And what they wanted to find out was how serotonergic input from the dorsal raphe nucleus modulates spontaneous and evoked activity in the visual cortex, and are these effects mediated by distinct serotonin receptor types. So how they got on about doing this was to stimulate the 5-HT neurons in the DRN. The researchers used transgenic mice that express channel rhodopsin 2, also known as CHR2, selectively in the serotonergic neurons. Then blue light was delivered via an implanted optical fiber, activating CHR2 and triggering serotonin release across the brain, including the visual cortex. But they measured neuronal activity using wide field calcium imaging, so they modified the neurons in the V1 to express RCAMP, which is a red fluorescent protein that increases in brightness when calcium binds with it, so it correlates with neuronal activity. They wanted to measure both anesthetized and awake mice, so urethane was used as the primary anesthetic, and sometimes chloroprotixine was used as a sedative in combination. And finally, pharmacology-wise, they used MDL and Wei as 5-HT2A and 5-HT1A receptor antagonists, respectively, to measure the effects of these specific receptors on activity modulation. What they found out was stimulating DRN 5-HT neurons greatly reduced V1 activity, and without any visual input, the spontaneous cortical activity dropped below baseline levels. If you bring your attention to the figure here, we see in the y-axis numbers ranging from 1 to 8. These are the mice. And here we see the visual, when the visual stimuli are presented, which are graded lines differing in contrast, and the time duration. So here in the AI, we see visual evoked response without photostimulation, and here when there is photostimulation, we can clearly see reduced V1 activity when there is photostimulation. And also in the spontaneous activity, if we look at here and with photostimulation, even though it's in baseline, around baseline here, it drops below baseline when there's photostimulation. Also in anesthetized mice, serotonin caused a stronger suppression of baseline activity, whereas in awake mice, the baseline was less affected, as you can see here. This is the spontaneous activity decrease, and here is the awake and anesthetized conditions, and it can be seen here that in awake mice, the baseline is less affected than the anesthetized mice. And finally, 5-HT2A activation specifically reduces the gain of sensory evoked responses, whereas 5-HT1A activation silences ongoing cortical activity. So here in A, we see in the y-axis magnitude of suppression. This is the control. This is MDL, which I talked about, that is the antagonist for the 5-HT2A receptors, and this is Wei, which is the antagonist for the 5-HT1A receptors. And what can be understood from this is when the 5-HT2A receptors are not in effect, they are antagonized, the magnitude of suppression in the evoked activity is decreased, which means that 5-HT2A activation specifically reduces gain of sensory evoked responses. And if we look at B here, the same can be said for spontaneous activity and the 5-HT1A receptors. When they are antagonized, there is no magnitude of suppression, there's no reduction in the spontaneous activity, meaning that 5-HT1A receptors are responsible for the suppression when there is spontaneous activity. So, in conclusion, serotonergic input from DRN exerts separable, divisive gain control over spontaneous and evoked activity in V1 through distinct receptors, enabling state-dependent modulation of cortical responsiveness. Thank you for your time.